about the mixer. We talked about when we have, let's say, few inputs or incoming channels, and we have the mixer here. It will do the mix and will send the relevant audio information, audio data to the user in the outgoing channels, and it will do the mixing inside. The mixer is also responsible for sending the correct data without sending, if I'm speaking, my audio will not get back to me, and the experience will be good. We also talked about algorithms we have here, for example, the AGC for reducing noises. We have the VAD, the voice audio detection or voice activity detection. And we talked about, if I remember correctly, we talked also about these entities inside the map object. The presentation also, you can refresh your memory and see in the presentation that they are also the object that defines these entities. Okay, so this was the map, and the map is the audio processing, media audio processing, and now today we'll talk about the MVP, which is the media video processing. If you have question on the map, this is the time to ask.
Mm-hmm. Mm-hmm. No questions.
Okay. So, I will show the presentation in a second. I just want to say something before we start. In the video processing, we don't have the mixer, of course. So most of the items here are the same. We have a conference, we have a call, we have channels. Usually it will be incoming channels and outgoing channels. But if you remember in the map, when we implement the channel, we implement a chain. An MF chain, which is built in nodes. Each node is responsible to do a specific work, a specific job, and we talked about the incoming chain, which is the ingress, the mixer, and the outgoing chain, which is the egress. In the MVP, it looks slightly different. In the MVP, we talk about inputs and outputs, or a different name is decoder and encoder. If in the map, the decoder and the encoder were nodes inside the incoming and outgoing chain, in the MVP, it doesn't look like this, because we're sending the data to the DSP guys, to David, and David decodes and encodes the stream. And once he finished the job, he sends the buffers, the data, to Giorgio. to handle the data from the network and to the network. So there is something like that. There is, again, we're talking about a chain, but here we are sending the data to DSP decoder, and then the encoder, and then the outgoing chain, the outgoing nodes. So this is how it looks in the MVP. We are sending the data. In the 8.5 version, which is our last, we're using a shared memory. I'm not sure you had the presentation, but you will have the presentation on it. It's the RVIPC, which is the interprocess communication, the way we send the buffers from the MP layer to the DSP layer. This is the way it is sent, and vice versa from the DSP to the MP. Okay. Okay, so can you see the presentation?
Yes.
Okay, great. So we'll talk about overview, control object mapping, and I'm not sure we'll talk about debugging. This will be another session with Itzik about the logs. Okay. I will not get into too much details here. I will just say that the MVP has these building blocks, or uses these building blocks. We will talk about my presentation was stopped. Just a second.
Mm-hmm. Are you using a cable to connect the PC to the endpoint?
Yeah. Yeah, today I'm not using the screen link. Okay, so I will try to increase the fonts here, enlarge the fonts, and okay, so we can talk about, you can see the transport, the MVP, if you remember, like the map, is connected to the MCU application and to the DSP. When we refer to the transport module, we refer to the transport between the MP, the MVP, and the MCU, which is the MCU application.
Okay.
So from one side, it is MCU MP, this is the transport layer, and from the MP to DSP, it's the RVIPC layer. This is the transport layers. When we say, like the map, when we talk about the MVP core, this is the control part of the MP, of the process. It can be map or MVP. So this is the building block that responsible to receive control messages from the application and from the DSP. Actually, there are controls that are translated also from the network, commands from the network that are sent to this module as well. For example, if we are getting RTCP message to reduce the bandwidth, we'll receive this command to this module as well. The GOVL, G-O-V-L, which is responsible of the graphic overlay module, configuration, util, MF. We talked about the MF, which is the media framework. Notice that this is the same MF that we talked about last session. In our last session, this is a generic module that implements the nodes and the design pattern we talked about, which is chain of responsibility. So this is the MF. The FECC module, which handles the far-end camera control, controlling the camera of the distant camera. And the DCL module, which is the interface. Actually, it's a wrapper for interface to the DSP. So the DCL uses the IPC actually. This is the infrastructure building blocks. We use actually there are more, but these are the important ones. We use the software infra, the board infra, MP infra, and logger infra. All of these infras can be used, and all except MP infra is used in all other processes. For example, also the MCU application process uses them, the map process uses them, and the DSP process uses them. They are generic verbs inside the clear case. RVFC is also infrastructure module that also implements, for example, sockets or threads and many others implementation are inside RVFC. OS layer, not sure we want to talk about more building blocks. I think this actually explains about the modules in the MVP. In the past, we could use the MVP. We could use multiple MVPs inside one MCU. For example, one MCU application uses 2 MVPs and 1 map process. So that should theoretically should work. It works in the past, and the idea is to be more scalable. If you want to get more, or to buy, as a customer want to buy more processing power, want to be able to do more video conferencing sessions or calls, you can buy only MVP card or something like that. This is something that our architecture is supports it, and we can use it like that. Today, in our current implementation, we use 1 map process and 1 MVP process. One of our challenges in the near future will be to use a multi-core architecture and to use and to run the MVP and the map on multiple cores according to what the environment has. Okay. When we load the MVP, or when the MVP initializes, it loads these modules. The order of the modules is it goes as it's written here. The utility, the configuration, the transport, DCL. Transport is the, as we said, is the transport between the MP and the MCU application, and the DCL will be the implement the transport between the MP and the DSP. Media, Govel, graphic overlay, and core. The media layer handles the media itself and the buffers, the RTP buffer that are delivered from one node to the other. The media layer is responsible to move all the buffers to all chains in the MF. So once we notice that we're loading the configuration module first. So once we have the configuration, we know exactly how many cores we have and how many, what is our license, for example, how many cores we support, or how many sockets we need to open. This is in the configuration, and once we have that, we can load the media and then load the core task. The core task, once we have the core task up in the air, we can start and receive commands, control commands, for example, open conference or open call, and we are ready to be used. Okay, we talked about the scalability of the MVP. Not sure we need to go further in this slide. I will just say one thing. It's I will refer to the single context. The MVP core, only the MVP core task is a single context. The media can run in few threads, or we can divide them. As I said, according to what we have in the environment, we can decide that we want to run multiple instances on multiple cores. But the core task, only one core task exists. Only one manager actually received all the commands and sends them to the workers. Okay. We will not get into details in this slide, but notice that you can grab a look, have a look on it later on. It explains all the modules in the MVP and the relations between them. The core manager, the MVP core manager, is responsible to what I said about receiving commands and sending control commands to the application, from the application to the DSP, and from the DSP. It uses core object pools. It's very effective if we it can maintain very large entities or object inside it, but the access to it is done with O of 1, which means it's a direct access. It also maintains a timer. Every object in the system can use the timer management or timer services, which is implemented here. And it also it also maintains a bandwidth regulation for using the whole bandwidth of the whole system. For example, if we want to open, or I would say in previous version, we had few problems in supporting full capacity with full bandwidth. So if we're getting to a situation like that, the bandwidth regulation can allocate low resolution or can reduce the bandwidth a little bit to all the calls, so to achieve full capacity work. So this is also done in the core manager. If you have questions, please feel free to stop me and to ask.
Okay, sure.
Okay, so now we will talk about the component, the object inside the MVP, the main object. The first is the call group or the conference, as I wrote in the whiteboard. So the call group contains the calls and manages the shared participant control objects. Open call, the open call, as we talked about. One thing we didn't talk about is the shared object. The application can open a shared output and assign it to the call group. Notice the regular output will be opened inside the call. We will have a call, we will have a channel, two channels, input and output, decoder and coder. But this is a shared output. This output is relevant for the whole conference. For example, if I want to send presentation to the same presentation to all participants in the conference, I can do it using one shared output. This is the idea to save resources. We also uses the shared output inside our software switching handling. And this is something I want to show in the whiteboard. One of the processing we are doing in the MVP or one of our main logic, or there are a lot of logic in the videos is the video switching. We're doing video switching process, which means no DSP. And for that, we can use, actually there are a lot of few configurations. We can send the data, send the buffers, the RTP buffers, to the input software. This is software, not DSP. And the input software can send the data to the output software and to the participant. Actually, it will not look like this. It will look like this. If you remember from the mixer, this is the same idea. Buffers that received, if this is a call, and this is another call, buffers from input 1 will go to output 2 and to the second participant. We can do it in switching, as I said, and when we are using this mode, there are no DSP processing. Getting the buffers, doing network optimizations, doing network resiliency. We can do FEC here. We can do NetSense, which is, we'll talk about it maybe in a different in the way that can improve the resiliency of the network. This is the software processing. This is a regular software switching, and the one I started to show in the presentation is the shared output. Now, once we understood how the software switching works with two participants, let's talk about opening shared output or shared encoder. It can be software encoder. And in the conference, the big box, the big square is the conference. In the conference, we open 3 output or software outputs. And inside there could be many calls. Call 1, call 2, and so on. These software outputs are part of the conference and are used for our software switching logic. We have also such configuration or such setup. Not in all software processing we're using such a configuration, but this is one of our options. We can, the output can, let's say for example, or let's start from the beginning. Do you know what is the experience, what's the user experience of the software switching comparing to DSP process?
No.
Okay, so actually this is important to understand. The software switch